Hello guys, how are you? This is your teacher for economic statistics again, Jun Lee. Those of you who haven't actually went through the syllabus, please go through it and come back to this lecture. This is our official first lecture, but I discuss some housekeeping stuff over there, so please take a look at. So how the course is working is, as you know, this is gonna be an online course. So I will record the lecture just, maybe a couple days before our official days, and then I will post it. And you can take and look at the lecture whenever you're available. So you can take as many as times you want and just, yeah. So there are some benefits. For example, if we are confused or if we miss some lecture, you can always take it. So also, I'm not taking official attendance, so that will be also beneficial. So some of you might be in other countries, due to the COVID, and you might stay at home, in other states, something like that. So you can take this lecture without any time restriction. That is another beneficial. But as you know, I mean, one of the drawback is interaction is quite limited, right? If you have question right away and you might not know, I mean, okay, you can raise your hands and you can ask during the class, but in this distance learning is kind of like limited. Sometimes I will have just live Zoom interactions with you before the exam, etc. But I know some of you cannot attend a certain time and some can, and hard to find our official, the class time. And maybe some of you guys might have, overlaps and duplicates, and others cannot join at certain times. So I think this is the best way. But to overcome those limitations, I'm very flexible and available in, through emails, etc. So if you have any question, shoot me an email. If needed, we can have like a Zoom meeting, one-on-one meeting, or phone call, or I can try to answer any question through the email, okay? Don't be shy, and you can always reach out to me, okay? And then, okay, I mean, one of the limitation in distance learning is it's hard to share contents, or sometimes, I cannot write on board, etc. So to overcome that, I purchase some device so that you can see my handwriting at the same time, okay? So how is it working is as follows. So I will show you that. That is, okay, let me make this pin video. Okay, you probably can see this one. So this is how it's working is when I handwriting this. So hi, everyone. Okay, see, can you see my handwriting? So if needed, I will just write on hand. So it's like a board. So I think this is will be working very well. But if you cannot see this, or etc., and always let me know. Also, I can share my contents. Like for example, I can share my desktop over here. Probably, am I sharing correct screen? Right? Okay, let me share again, just in case. Okay, desktop one. Okay, so this is our first slide, and then we can go over it. So if you need it, I will just write do the handwriting, and then we can work from there. So first section is probability, and those who haven't go through the syllabus, please go through that. We're gonna have 12 slides, slide 1 through 12. So first one is slide 1 through 5 will be on the first exam. The tentative exam schedule, first exam will be September 20, I think when was it? September 28th. But they might be subject to change anytime. So bear with it. Also, each week you're gonna have one exercise. So each exercise will be 2% of your grade, okay? So, okay. And the due date is on syllabus, and also I will upload it and then set a due date so that you can submit by the that time. So you can submit the homework in Blackboard, okay? So there are two common ways of describing data. So there are some respective chapter. As I said, each chapter contains some the corresponding textbook. So this is based on 11th edition of a textbook. So it might be different if we are using older textbook, but always take a look at what is the probability in your current textbook. So if you actually don't have those textbooks, it's fine. Any other statistic textbook is fine, or online resources. I think my slide is quite comprehensive. So if you can follow it without any problem, then you don't need textbook. But if you want some supplement, then that will be fine, okay? So probability of an event is a proportion of time that the event occurs when the experiment is repeated many times. So what is the meaning? So let's do some examples. So let's say 50% is the probability of heads from a coin toss. So here, the coin toss is experiments. Like you are doing some experiments and some events, for example, heads or tail might happen with some probability, 50% time. So the event is like a heads or tail. Those are events, but whatever you're doing experiment, those are actually experiments, like flipping a coin or roll of dice or whatever activities you are actually doing. So, but whatever outcome, that is actually probability. For example, you are flipping roll of dice like 200 times, but and you had let's say some 40 numbers of 1 appear in the 200 times of rolling a dice. Then what is the probability? That is actually 40 over 200. It's actually 1/5. So I mean, those kinds of things are some example of probability. So definition of experiment is some action that generate the randomness. For example, flipping a coin or roll of dice, that are some action that generates those randomness. And event is a set of outcomes. In above example, it will be heads or tail. In dice, that will be number 1 through 6. That will be set of outcomes of the experiments. So possible outcome would be head or tails. So probability of, these are some fundamental. Probability of neither heads nor tail is 0 because those are impossible, right? So, but probability of heads is 0.5 and probability of tail is 0.5 as well, but probability of heads or tail is 1. So that is like a union concept, but that is, I will explain this more detail later, but these are some intuition because when you flip a coin, it's gonna be either head or tail, no matter what. So that is what, or it's 1, but neither head or tail, that is impossible. So that's why it's 0. So percentage fraction and decimal, those are interchangeable. That means, so 50% is 1/2 or 0.5. Those are all same. They are same. Okay. For example, probability that when you flip a coin, the head will come up is 1/2 or 0.5 or 50%. Those are meaning exactly the same. So, but you don't say 0.5%. So when you want to put percentage at the end, it should be percentage term, like a 50%. You should multiply 100 in the second and third numbers, okay? So some question, find one that, is not a probability. So you might want to pause this video and try to answer this, and what would be the answer? So if this were actual in-person class, I would give you 1 or 2 minutes, but please take your time. Maybe you might want to pause and think about, that find the one that is not a probability. Can you guess anything? I mean, So I will reveal the answer. The answer is D. So why is D? Because why do you think it's D? I mean, you might want to pause again and think about why the answer would be D. For example, A, from a dice, 6 comes up is the probability is 1/6, right? For example, you can throw dice and then dice show up 6 times and you can write as 1/6, right? So, so that is actually population parameters and population probability that we're gonna talk about this later. But the thing I talked about in the earlier, for example, when we roll a dice 200 times and maybe 50 or 40 will come up, that is actually sample. I will differentiate that later, but for now, just take it as is. So we can write as 1/6, and why B is working because experiment is a free throw, event is a succeed, and then out of 8,772, he made this many. So you divide 7,327 over 8,772. That is 0.835 or 83.5%. So that is how you get that. And C, so experiment is going to tomorrow and checking the weather, and event is more than an inch of snow. So so this is also we can set as the probability. And why do you think that one is D? Why do you think it's D? Because okay, let me come back D shortly. But for E, 70% of customers are satisfied with the last run. So that is experiments is choosing a random customer. Event is answer from the customer is satisfied. So such an experiment is called a survey. And finally, D is not a probability because it's just outcome rather than a probability. I mean, because of the COVID, Dow Jones index dropped like 40%, for several weeks, but it just, coming up again. So that concept is like outcome. It's not actually probability. So that is a little bit different. So when you can write in terms of experiment events, something like that, then those are the probability. But when you cannot, then that is not a probability. So these are some examples of data set. I will probably show you later, but because in our project, we're gonna actually use some of the data sets. So some data set might have, okay, what is your gender and what is your birth year, what is your race and what region are you living, what is your education and what is your income, something like that. Based on this data, we can analyze, okay, how the education affects your income or how your gender affects your income, something like that. Those are the regression analysis. We're gonna do it later. But you first need to understand the data structure in detail. I will explain you this using our program, and by looking at some Excel file later, I will post some interesting data. I will discuss that later. So how the data is structured is as follows. So each row is experimental unit. So that means each row represents, like when someone did some survey, like someone asked you, okay, what is your gender? What is your birth year? What is your race? What is your region, education, income, etc. They might fill out some couple of pages of survey, and each of that observations information are recorded as one row. So from this table, how many rows we have? 1, 2, 3, 4. That means we have 4 people surveyed in this data set. But of course, this means there are tons of more. So this data set might have a couple thousand of people. And so sample size would be like a 5,000. That means 5,245 rows. So each column is a variable. So each column represents its gender, birth, race, region, education, income. And okay, so take a look at this. And we might want to differentiate what is the population and what is the sample. So population is, basically, literally it's a population. Let me show you my handwriting. So let's say in the US, we have this many people, right? So, but we want to analyze something effect of how the education on income, something like that. But the thing is, we cannot survey for 100% of people. So 100% is basically population. Population is 100%, but since we cannot survey 100% of people, I mean, it's a very costly and then also time consuming, etc., etc. So what we usually do is, get some small fraction of people, it's like a core sample, and try to guess the population parameters. So that is actually statistic. So statistic is when you're trying to use some samples, try to guess the real parameter, or parameter means something we are interested in. For example, effect of education on income, something like that. I will explain that more detail later, okay? So statistic is to guess the population using a sample. Yeah, give me a second. Yeah, statistic is to guess the population using a sample. That is core statistic. Basically the purpose of our course. So we have some sample and try to guess the population using this some small sample. So population probability is actually when you do some experiment infinity of times, that is what you are getting. For example, when you're flipping a coin, we know that the probability that the number 1 show up when you flip, actually flip a dice is 1/6. That is a 13.33%. But in the sample, that might be different. As I said, okay, maybe you flip 200 times, but by chance, 40 out of 200, which is 1/5, will come up. That is sample probability. But as we have enough sample or do the infinity times, then it's gonna be reach to the population probability. That is called log large number, but that will be, we're gonna learn in probably 3 weeks from now or something. I will explain as we go. Okay, so as they mentioned, like a sample probability can be different due to the randomness of the experiments. Because sometimes when you roll out dice 200 times, I mean there are still chances that all the same number might come to 200 times. So for example, when you roll dice 200 times, but all number ones can come up in 200 times. I mean there are still chances. So that is actually some randomness going on in sample probability, but in population probability, we don't have any randomness. So the frequency distribution table, which we're gonna use later a lot, is the count of the observation for a value. So the data in this in this presentation actually had 5244 sample size, but out of them we have 1139 out of 5244 are actually residing in here, North Central. And then 808 are living in Northeast, etc. So that are called the frequency. So basically, we have 5,244 observation, but we want to know them by frequencies, like how many of them are living here, etc. So these are some Excel function. So I'm gonna post some data set for our final project. And you can take a look at, okay, using this pivot table, we can create this one. So maybe you can use some combination of micro Excel and then R program to produce this, or, but in the slide, mostly I will talk about Excel because that one you can access very easily, but I want you to also focus on R program as well. So because R is free, but later, probably next week or the following week, I will give you some instruction. But for now, you don't have to know R, but make sure you download it, okay? Okay, so using some pivot chart, you can make some distribution like that. These are not hard. I will explain that later when we are going to discuss the data section. So sample probability is total frequency over n. So previously I said, okay, so if I roll a dice, but 40 out of 200 experiments come up the number one. So that means, okay, how many came up? That is 40. How many sample did we do? It's 200. So that is 1/5. So that is how you get that. So the numerator is like a frequency. And this is total number of observation. That is your probability of something. That is the idea. Okay, n is the sample size, and that is a probability, and that is a frequency. For example, these were your frequency table, right? And then you can convert this to probability. So 1139 over 5244, that is 21.72. That means, oh, okay, the probability that someone is residing in North Central is 21.72 based on this sample of 5244. Right? Or similarly, you can say, okay, probability that somebody is living in South is about 40%. How did we get that? It's from here. So the summation of probability is always 100, right? That should be, but make sure you know how to convert this frequency to probability. It's not hard at all. Just frequency over total number of samples. So practice this, okay? And using this, we can also convert this to probabilities. Okay, multivariable analysis. So this is some kinds of real, life example, but of course the numbers are just made up. So now we consider two variables together. Previously, we only had one variable. So let's say a New York State household survey gives the following result like that. So probability distribution of income is like that. That means, so, there are 80% of people who are making income less than $500,000. Yeah, and like 20% of people make more than $500,000, and 60% of people own a house, and then 40% people do not own a house. So again, these are some number I just made up. So STAR is a New York State school tax relief program. And to be eligible for the basic STAR, one must be own a house and on less than 500K. So you should have this combination. So to make government budget plan, it is important to calculate the probability of those who are eligible for the STAR program. So based on the information, okay, do you think we can calculate the probability of in the STAR eligible people? Please take a couple minutes at least. And try to answer this one. You might want to pause this video as I will reveal the answer shortly, and then try to answer this. What is the probability of STAR eligible people? So what is your answer based on that? Try to guess. Again, this will not be graded, but for your own understanding, it's better if you can pause the video and try to answer this, okay? The answer is, we cannot calculate from the given information. Why? To calculate the probability, we need to know the probability distributions, because we only know the distribution of this, income, $500,000 or less or more than this, but we don't know how many people are owning a house and making an income less than this. Some might think, okay, we can maybe add this up, or we can maybe multiply this, but no. Because, it's possible that, majority of the people who are owning a house might just, make an income less than 80%, So it's not like basically related. So the maximum possibility and minimum possibility are this. Can you guess why we got this table? So do you think you can try to recover this from, from that previous page to here? So let me show you how. Okay. Okay. So you wanna the given information is like that. Income 500K or less is 80%, and income more than 500K is 20%. And there are 60% own a house, and now don't own a house is 40%. So later, what we're gonna notice is these are actually marginal probability. So marginal probability means it's like when we have two or more variables, we want to know the probability, something like that. So each of the probability inside of this called a joint probability. So that is a joint probability. So joint means, for example, probability that somebody is making 500 or less, and this is N or intersection. I will cover this later more. And own a house. So that happens at the same time, right? Somebody is making less than 500K and own at the same time. So we want to find the probability. So that is jointly happening at the same time. So that's why it's called joint probability. But the marginal probability is something, is it doesn't matter. For example, for this probability, it doesn't matter whether somebody is owning a house or not, right? So it doesn't matter for them. So for example, the income less than 500K is of 80%. So based on this table, which one do you think we can fill that? So that means regardless of their status of owning a house, the probability that somebody is making less than 5K or less is 80%. That means regardless of their owning or not owning the status, the probability that someone is making 500K or less is actually here, it's 80K. So that is no, not 80K, sorry. It's 80%. So that is called marginal probability, or summation of these two probability would be here. So let me write down here again for clarity one more time. So that is 5K or less, and it's more, and this is not own and not own, something like that. So summation of this probability should be 80%. That is, again, marginal probability. So marginal probability is summation of everything, or it said, in other words, is probability of 500K or less. In other words, that is, okay, what is the probability that somebody is making 500K or less? That is called 80%, that is marginal probability. So we got the evidence that summation of this is what, 80%. So we know that, okay, somebody is making more than 500K is 20%. So this is more. So we know that this summation would be 20% again. Similarly, we know somebody is owning a house is 60%. So we know marginal probability or probability that somebody is owning a house is 60%. Similarly, this is 40%. So these are all the information we are know. So we don't know the inside information. So given that, the summation of this one and these two numbers is 40%, and summation of this one is 80%, and summation of this one is 20% again. How can you know the distribution? We can find the minimum and maximum possible distribution. For example, what would be the minimum distribution? For example, we know the minimum, to find the minimum and maximum, we also need to find the minimum and maximum, right? What is the maximum it can go? Because summation of these two should be 40%. So the maximum it can get is what? 40%, right? So I will just max max of this is 40% because summation of these two would be 40%, so it cannot go more than 40%. And what is the summation of these two? That is 80%. So that means given this is max, that is minimum, right? Minimum is 40%. Why is minimum? Because this is maximum. This is maximum means it's because summation of these two is 80%. So if this is maximum, then this is minimum. So, and another thing is, what is the minimum it can go? Can you guess? You might think, oh, minimum should be 0. Yeah, you're kind of like right, but it's no, because you need to think about other things. I mean, 0 might be a good guess, but thing is, when you put 0, what would be this number, this max number? If this is 0, because summation of these two numbers is 80%, so it should be 80%. But summation of this and this number should be 60%. Do you think it's feasible? No. Probability cannot be more than 60%. So the maximum it can go is 60%, right? Because it cannot go more than 60%. Otherwise, the summation might be higher than that. So then what is the minimum it can go? It's 20% because summation of this is 20%. So similar reason, you can fill the other number. For example, this number, if this is 40%, that would be 20%. If this is 20%, it's going to be 0%. And consistent, if this is 40%, this is 0% equal 40%. 40%, 20% equal 60%. And 40%, 40%, if you summate that, 80%, 20% plus 0%, 20%, same. So if this is 60%, it should be 0%. If it's 0%, it should be 20%. Oh, similarly, summation of these two is 40%, summation of these two is also 60%, and vice versa. So this is how you get the minimum and maximum number, okay? Okay, let me show you, I'll share my screen again. Okay, so these were the thing we just discussed, okay. This is how you get this maximum and then minimum possible eligibility, right? So please take a look at this carefully and see whether you can distribute the or get the same outcomes, okay? So both imply the same probability distribution for income and house ownership. So the marginal probability is, as I just said, the probability distribution of a single variable. For example, probability that somebody is owning a house, probability that somebody is having income higher than 500K, etc., etc. So we know marginal. So based on this marginal probability, we can guess what would be the some range of the joint distribution. Joint distribution was what? The probability distribution of multiple variable. So previous, the example we had was whether somebody is owning a house or whether somebody his income is higher or lower than 500K. So with the combination, for example, probability that somebody is making 500K or less and owning a house is a certain percentage. So that is a joint probability. So even if you know the marginal probability of two variables, you cannot recover joint probability, joint distribution of them. I mean, you can know, you can guess what would be maximum or minimum, but you cannot recover exact value. But on the other hand, if you know joint distribution of them, you can recover marginal distribution. For example, let's come back to this example. Let's say you know this distribution. For example, let's say pretend this is a real distribution. Let's say you know this is 40%, this is 40%. Of course, each of them is joint probability, but you can guess this is 80%. That is a marginal probability. So based on the two joint distributions, you can infer, guess, the marginal probability. So if we know joint probability, you can get marginal probability. But if you know marginal probability, you cannot get joint probability. So, okay. So back to this data set, using this frequency table, we can get this distribution. Later, I will show you this in detail, how we get that, but let's take this as given, but you can already work on a pivot table in Excel file. Let's say we have a two variable. Previously, what we had was over here. over here. So based on the region of residency, you can get the frequency and you can get the probability. So that was a single variable case, but now you have two variables, right? So for example here, so one is their gender and the other is their region of residence. So you have a two variable and 8 possible outcomes. So sample size, how we get the sample size? You just add them up. 523 plus 397 plus etc. So finally you get the sample size. And the next thing you want to do is you convert this to probability. How did we convert this to probability? What is the sample size in our sample previously? It was, I think, 5,000 or something. It was 5,244. So how did you get the probability? We can come back to this, like, using the similar step. Sample size was 5,244. You can just add them up. So one is NC, NE, S, and W. Okay. And the female and male. So it's 523, 397, 1031, 576, 616, 411, 1046, 644. So you want to convert this to probability table. So how do you do that? As we did before, divide the frequency. Again, the probability was what? Probability that something like NCNF, that is again the joint probability because you want to know what is the probability that somebody is living in NC and then also female. That happens at the same time, jointly at the same time. But the probability that somebody is living NC is marginal probability because that is not function of F and M, or whether they are female or male doesn't affect your total number or probability. So this is marginal probability and joint probability. So we want to convert this to probability table. So write the same, NE, S, and W, female and male, something like that, using joint probability formula, as we learned before, that is what? Total frequency over sample size. What was our sample size, for example, here? It's a 5244. How many of frequency over here? Is 523. So if you do the math, you're gonna get some probability, right? So that is how we do that. And so that would be 523 over 5244. That will be 397 over 5244, etc. So yeah, that is how you get that. So once you, let me come back to that and share the screen again. And finally, this was our outcome. Divide that. This is our probability, right? So that is, you can get this using pivot table in Excel, but always you can just do manually. So the summation of all the probability must be 100. If not, there's something wrong, or maybe it's a rounding error issue. So this is your job. What is the probability of female? So can you try to guess this one? So I'm asking you, what is a probability of female? So I will give you please pause this video and try to answer this, okay? So I want to take a couple of minutes and try to answer this. So what is the probability of female? So yeah, I pretend that you already paused your video and get your answer. So now we can check your answer. So probability of female, did they ask probability of a female and living in NC or NE or etc.? No, this is marginal probability. They are asking what is the probability of female. What is the probability of female? It's summation of all the probability here. So probability of female is a probability of female who are living NC plus probability of female who are living NE, probability of female who are living in S, and plus probability of female who are living in W. intersection W. So each of them is joint probability, but summation of everything, or this first law is over here, that is a probability of female. So in other words, that is marginal probability. So the question asks you, what is the probability of female or marginal probability given this joint distribution? Does that make sense? So let's come back to the slide. Okay, what is the probability of female? Just that means add this whole number. So that is, yeah, just add them up. Or number, event of female includes 4 outcomes. So probability of female is a sum of 4 probability. So each of these probability is again joint probability, but some of this would be your marginal probability or probability of female. You know, so okay, what is the probability of a female who are living in NE? So can you guess? Again, pause this video to answer this. So you are asked to find probability of female who are living, because it happens at the same time, so this N. So it's intersection. So probability of F intersection, that is intersection. And E. So because they are happening at the same time, somebody should be female at the same time, they should be NE. So that is intersection, that is joint probability. So that is what, based on this example. So the probability that female, so look at this law, and who are living in NE, only point we can find is here, that is joint probability. So answer is here. How easy it is, right? So what is the probability of a target consumer? So again, you know, take a moment, pause this video and try to answer this. So suppose new SUV is launched, target customer are either female or it's or, right? So this is important. And it's not and. And means it's else happening at the same time. Or means it's either female or living in NC or again NE. So that means what? So let me come back to this and let me explain. So before I reveal the answer, try to answer this question yourself, okay? NC, NE, SW. Female and M. So the idea is, okay, they are asking what is the probability, there are key difference. This N is happening at the same time. So that is intersection. So that is a joint probability. But there is another thing you need to consider. It's like a probability that somebody is a female and or is always a union and any, for example. So that means, you know, they can be either female, they don't have to live in any, but they can be either female or any. So basically you need to include everyone that satisfy either of these. That is called union. You probably learned this in some high school year. You know, this, when you have an event A and B, this is intersection, right? This is intersection. So that is intersection like that. So A intersection, not B, and this is this one is A union B, A union B. So this union is usually or. When someone asks you or, that means it's union. This is like and, okay? So the question asks you or. So can you try to answer this? So let's come back to here. Okay, so they are saying, what is the probability that somebody is, they are asking, what is the probability that somebody is a female or living in NC or NE? So so let's look at that. So what is the probability of female? That includes everything here. For example, I'm just marking here. And what is NC? Okay, NC contains this one. What is NE? And basically this one. Oh, basically it's or. That means it's, I said union. That includes everything. So just add this probability plus this one, plus this one, this one, this one, this one. Because the reason why it says or. Does that make sense? Because that is a union. You are including everything. So first look at probability of female and or and C, that is here, and look at any and over here. Oh, okay, so includes everything. Doesn't make sense. But what if I'm making some question, like what if the question is like NC, NE, S, W, female and male. So what is the if question like somebody is living in NC and NE. So that is intersection. So that is intersection is and it should be happen at the same time, or it's like a common. It should be happen at the same time. Do you think somebody can live in NC at the same time they are living in NE? There is no common point. So answer is no, there is nothing. But what if, so for intersection, it was nothing. What if the question was somebody is living in NC or NE? Then you take a look at that. Okay, somebody is living in NC and or NE. Oh, just add them up, add the probability. So let's come back to the question again. Okay. Okay, so answer is, oh, just add them up. So take a look at this one again. New events, either A or B is a union of A and B. It basically covers everything. When you have an A or B events, or means it's union, and means intersection, and A does not happen as complement. So what this means is, what is complement of female, female complement or. So if someone is not female, then that should be male. So that is kind of complement example. Or what is a complement of NC? Then somebody is not living in NC. That means they should live in NE, S, or W, or any of this region, right? So based on this example, what is the probability of F union W? So female union or, again, this U is or, so F or W, can you guess? So again, pause this video and try to answer. I will reveal this answer right now. So somebody is living in, female and, or W, so you need to add them up because this is union. But note that probability of F is this and probability W is this. When you add them up, it's never equal this. You know why? Because when you actually add them up, you add this one plus this one, but you actually exclude 10.98 because of duplicates. So you naturally exclude them at your end. So to get the exact formula, it should be like that. So probability of A union B is probability of A plus probability of B minus probability of A intersection B. So each of them is like a marginal probability, and this is joint probability as this is intersection. So, but when you actually use the graph, you naturally, when you add them up, you naturally actually eliminating the duplicates or the joint probability of this. So, does that make sense to you? So what you actually did is following. So what you did was, okay, probability of F, which is 9.97% plus 7.57 plus 19.66% plus 10.98 and plus 10.98 plus 12.28. So this is what probability of female, and this is what probability of someone living in W, and you subtracted the duplicates 10.98, which is probability of F probability of F intersection W. Okay, so that is how you did using this formula. Okay. Okay, so additionally, F and W includes all women and or people in West. So because it's double counted, so you are basically subtracting this. So I just explained you that. That is called addition rule. So what is the probability that S union W? So I will leave it the answer, well, you guys can pause and come back to this answer. It's basically this. You just add these numbers and these numbers. Okay, so, and this is a new definition. Event A and B are called mutually exclusive if the intersection equals 0. So there is nothing in common. So for example, in here, S and W are mutually exclusive because there is no common point, or it cannot be possible to have a common point. For example, they cannot live in South and West at the same time. So in union, so how you do this is, when you find the probability of S union W, technically it should be equal probability of S plus probability of W minus probability of S intersection W. But you are able to add this one because there is no common point. So you are basically subtracting 0 because the probability is 0. But when this probability intersection equals 0, then we call that as mutually exclusive. There is no common point, okay? But remember, if and only if this intersection equals 0 or no common point, then it's mutually exclusive. You're gonna have this kind of question in the homework, so just keep that in mind. So try to answer this one. So what is the probability that a randomly selected the person does not live in Northeast? Can you try to guess? So I will leave you the answer. So who are not living Northeast? This one, and this one. So one way is you can add it, this number plus this number plus this one. That'll be your answer. The other way is, oh, okay, we are looking for the who are not living. We know, or the summation probability is always equal 1 or 100%. So 100% minus 15.41% would be equal summation of this. That is actually complementary rule, right? So using complementary rule, probability of A not occurring is probability of A complement is equal this. So you can get this one, 84.59. But again, you can get the same number using by adding this number, but you can use complementary rule. When you have so many variables, complementary rule is always convenient, but when you have only few variables, either way it would be fine. But just make sure you understand this, okay? Okay, let's say this is some distribution of smartphone and then some providers. And let's say what is the probability of a target consumers of this event? Let's try to look at that. So suppose that Splint offer a free app, but it does not work on Apple. So Splint offer free app, but it doesn't work Apple. Can you try to answer? I will leave the answer in the following. Because we are looking for Sprint, and then it doesn't work Apple, so it should be either Samsung or other. So summation of this, easy, right? So, okay, here are some another example. Let's say these are the information we would like to recover full probability distribution. I will leave this as your exercise. Actually, it will be really good exercise. I will not explain in detail, but please try to do that, okay? But I will leave the answer, of course, in the end. But let's say 25% of potential consumer have a checking, 40% of consumer have a Visa credit card, and 50% have neither BOA account nor Visa card. Can you recover that? You might pause the video. Okay, 25% of consumer have a checking account. That is a marginal probability, right? And 40% of have a credit card. That is also marginal probability. So based on that, we can first make this kind of distribution tables, two-sided tables, and x plus z, summation of this is 25. X plus y is 40%. W equal 50%. So finally, summation of this is 100%. We have 4 unknowns, but we have 4 equations. 4 unknowns and 4 equations, we can get the final answer, which should be this. So please try to do this and whether you can get the same result. And similarly, you can get this information again using this one. So make sure you try this, and if you have any question, let me know, okay? So follow this step. So for example, 25% of them have the checking. So X plus G is 25%, and 40% have a Visa credit card. So Visa credit card, that is this one. So X plus Y is 40%. And neither of them have a BOA account nor Visa card. So W equal 50% and summation is 100%. Similarly, you can get this one, okay? So, so we just finished the chapter 1. I will post the first homework on Blackboard, and please try to submit by October 31st, okay? I will put that assignment in Blackboard, okay? So, the lecture will be something like this. I will record the lecture just a couple days before our actual courses, and you can take a look at. If you need it, we can have office hour, etc. Okay, you can listen as many as times you want, and feel free to ask me any question. Okay, then have a great day of you guys. Okay, and talk to you later. Bye.